Hello, Legacy Mathematicians. So today we're going to look at our last form of factoring, which is factoring using special cases, or the special cases of factoring. What you're going to want to have on you today, your notes, and then a calculator just to do some quick multiplication or subtraction or any of that nature, and then pen or a pencil as well. So, steps to special cases is not all that new from our AC method, okay? So very first thing we're going to want to do is identify what's A, what's B, and what's C in the polynomial. Now, something that's going to be a little different this time. B might not be in the polynomial. If that's the case, we can assume B is equal to 0. So that means we're just going to have an x squared and just a number. No number with x. Ultimately, that's what would happen. If that is the case, B would be equal to 0, because 0 times x would just be 0. Then we're going to multiply A by C, because we're going to use the AC method. We're going to find the factors of AC, okay? And then we're going to find two numbers. When you add them together, that's going to give us our B term. Replace it, and then factor by group or our box method. So let's actually take a look at an example here. So we got z squared minus 9. So very first thing, let's identify A, B, and C. So A looks like he's 1 because he's sitting in front of the z squared, remember. Our B, we don't have a B term. Notice there's no z in here, right? So there is a 0 for B, and then negative 9 for C. So now we're going to find our AC method. So 1 times negative 9, that is negative 9. So I'm looking for the numbers that multiply to give me negative 9. So 1 and negative 9, negative 1 and 9, 3 and negative 3, right? Now, one of these has to equal my B term, 0. So this equals negative 8 when I add, this equals 8 when I add, and this equals 0. There is my two factors that when I add them, I get my B term. In this case, it's 0. So let's go ahead and rewrite. I got 1z squared plus 3z minus 3z minus 9. Okay, now we can box. So I got z squared, 3z, negative 3z. And I just put that little tail on the z's so I don't get confused with a 2 or something. It looks like we have a greatest common factor here of z. Same thing here, z. Something times z needs to give me 3z. That would be 3. And then 3 times something needs to give me negative 9, which should be negative 3. And negative 3 times z is negative 3z. So my answer is z plus 3 and z minus 3 for that particular problem. Let's try another one like it. So I got s squared minus 16. So very first thing, A equals 1. Looks like we do not have a B term again, so my B is 0. And then C is negative 16. So if I multiply these two, I should get negative 16. So we're looking for the numbers that multiply to give us a negative 16. So 1 and negative 16, negative 1 and 16, negative 2 and 8, 2 and negative 8, 4 and negative 4, right? That's going to give me 0, which is my B term when I add. So I'm good there. Let's go ahead and rewrite my terms. So I got s squared plus 4s minus minus 16. Okay, let's go ahead and box that. S squared 4s, negative 4s, and negative 16. So I'm going to get S and S, 4S, and negative 4, right? Because negative 4 times 4 needs to give me negative 16. So I got S plus 4, S minus 4. Now notice, guys, do you see the pattern that's happening? I have, on my last problem, we had z plus 3, z minus 3. Notice, guys, square root of 9 is 3. Isn't that kind of neat? And square root of z squared is just z. Same thing happened here. S, 16, 4. Notice both of them had pluses, a plus and a minus factor. One was plus 4, one was negative. Okay? That's going to happen on every single one of these problems. It's kind of neat. So let's take a look and see, can we do this without having to use the box? It's going to make us a lot faster when we have to do these kinds of problems. So I know that they're going to have to be in two parentheses. One's going to have a plus in the middle. One's going to have a minus in the middle, because that's the pattern that it seemed to give us. And it always seemed like we had just the letter up there. So just S in this case. And then it was the square root of this number. So we need to know, what's the square root of 196? Let me grab my calculator here quick. 14, is that what you got? I got 14. So I know that this has to be 14. Let's multiply it back out. Let's make sure we get it. So we got s times s, that's s squared, negative 14s, positive 14s, and then negative 196. Notice, guys, how these two are going to cross out. That's why they have to be a plus and a minus, because then they'll cancel each other out. So we'll have s squared minus 196, which is our original problem. Thus, we have factored correctly. Now, I'm going to throw a little bit of a monkey wrench in that. What if there's a number in front of the letter? Don't worry about it. It's actually pretty easy. What we can do is we still can make our two parentheses, like that. One have a plus, one have a minus. But now, just instead of being just x up here, we're going to have a number with that x. Because, think guys, square root of 16 is 4. So we're going to have 4x and 4x sitting near the front right there. Then we can look in the back here and find our number here. It's got to be the perfect square that makes 81, aka the square root of 81. What is the square root of 81? Let me quickly do that on my calculator quick. 9, right? Square root of 81 is 9. And I'm done. I have found both first parts and both last parts of my binomials. So I get 16x squared. Notice if I multiply that, then negative 81, and ultimately they'll cancel out because I have a plus and a minus. So I have factored that particular problem down to its lowest terms. And that's the end of this video. See you later, Sabers.